In this video, I will explain how to find the point of intersection between two lines. So I have two examples for us to work through here. Let's check out this first example. It says, find the point of intersection of the line y equals 4x plus 2 and the line y equals 2x minus 6. So for this question, we'll notice that both lines are written in the form of y equals mx plus b. So this is known as slope-intercept form. Now, when both lines are written in this form, the easiest way to find the point of intersection is just to set the right-hand side of each equation equal to each other and solve for x. And then once we know x, it becomes very easy to solve for y. So let's do that. So we'll say 4x plus 2 is equal to 2x minus 6. And remember, we're trying to solve for x, so we're trying to get x all by itself. So we could start by subtracting a 2x from both sides. So on this right-hand side, these 2x's cancel out. We're left with 4x minus 2x, that's just 2x, plus 2 is equal to, over here we just have a negative 6. Now to get x by itself, we can subtract a 2 from both sides. So we'll be left with 2x is equal to negative 6 minus 2 is negative 8. And lastly, to solve for x, we can divide both sides by 2. So these 2's cancel out. We're left with x is equal to negative 8 divided by 2 is negative 4. Now what we do is take this x value of negative 4 and plug it into either one of these equations to solve for y. It doesn't matter which equation you pick, you'll get the same answer either way. So let's say we pick this first equation. So what we would get is y is equal to 4 times, we're plugging in this negative 4 right here for x. And then we have plus 2. So we get y is equal to 4 times negative 4 is negative 16 plus 2. So negative 16 plus 2 is negative 14. So we find that y is equal to negative 14. And just to prove that it doesn't matter which equation that you substituted x into, let's go ahead and substitute it into this one as well. So we would get y is equal to 2 times negative 4 minus 6. So we get y is equal to 2 times negative 4 is negative 8, and then we have minus 6. Negative 8 minus 6 is negative 14. So we get the same answer for y either way. So our final answer, our point of intersection, is going to be x is negative 4 and y is negative 14. This is where those two lines intersect. All right, let's try one more example. This one says, find the point of intersection of the lines y equals 1/2 x minus 6 and 4x plus 2y is equal to 8. Now, in this example, we'll notice that the first line is written in y equals mx plus b, so slope-intercept form. But this second line is actually written in standard form, which is ax plus by is equal to c. Now, in this case, there's a couple different ways to find the point of intersection. You could rewrite this equation to be in slope-intercept form by solving for y. Or another, perhaps easier way is take this equation, the right-hand side of this equation, and just plug it in for y right here into this equation. So let's go ahead and try this substitution method. So what we're going to do is write this equation, but we're just going to substitute this right-hand side in for y right here. So what that looks like is 4x plus 2, instead of y, remember we're writing this right-hand side of the equation. So 1/2 x minus 6 is equal to 8. So now we'll notice that we're only left with x's in this equation, so we can solve for x. So the way to do that is let's start by distributing this 2 into these parentheses. So we'll get 4x plus 2 times 1/2, that's just 1, so 1x, or just x. And then we have 2 times negative 6, that's negative 12, is equal to 8. So we can combine these like terms, 4x plus x, that's 5x, minus 12 is equal to 8. We can then add a 12 to each side. So these 12's cancel out. We're left with 5x is equal to 8 plus 12 is 20. And to solve for x, we can divide both sides by 5. These 5's cancel out, and we're left with x is equal to 20 divided by 5 is 4. So we know that these lines intersect at an x value of 4. To find the y value, we can just plug in an x value of 4 into either one of these equations. It doesn't matter which one, and solve for y. So let's go ahead and plug it into this first equation right here. So we would get y is equal to 1/2. Instead of x, we're going to plug in this 4 right here. So we get 4 minus 6. So y is equal to 1/2 times 4, that's 2, minus 6. And then we get y is equal to 2 minus 6 is negative 4. So the point of intersection, or the xy coordinates where they intersect, is going to be 4, comma, negative 4. That is where those two lines intersect.